James Smith.
Colin Mitchell.
We made Optical Theremin using, well, this is yeah, so
We have theremin, which is a type of musical instrument. We'll be describing it in a later slide. We implemented it using 2 distance sensors, which we also used one of for our present group. And the 2 distance sensors control volume and pitch of an output and tone. And the output can be wired to either a headphone jack, which we'll be doing so that we can have it a little louder, or just like a discrete speaker, so that you could theoretically carry it around with you if you wanted to. The theremin, since people don't know about it, we included a little bit of history. It's contactless, so you don't actually touch the instrument while you're playing it. And the original theremin was invented when Russians were doing research on proximity sensors. It was by a guy who was known in the US as Leon Theremin. And it uses the heterodyning effect, so basically you are one plate of a capacitor going to ground, and the antenna that you use to sense pitch is the other plate. And the variance in that capacitance changes the signal that is being output. And so instead of doing anything like that, we used software and proximity sensors to utilize the Arduino microprocessor.
So here's our block diagram showing the 2 sensors over here, one for pitch and one for volume. And they're just, if you don't know what the infrared ones are, they're just some sort of laser that measures distance and outputs a voltage. So we read that in through the analog to digital converter and did some fun math to convert it to a frequency, kind of like the Project 2 waveform generator. And then sent that to the DAC and ultimately to a speaker. And then the volume also controlled, like just the amount, I guess the total level that it could go to. And we also took the input pitch that was converted using all that fun math and output it to our LCD to display which pitch you're playing, more or less.
Yeah. And most of our features, it's an instrument, so it doesn't really have a lot of fancy features. But you can control the pitch. We have it varying between C4 to C5. It's like auto-tuned, so you play C and then you move it down, and eventually it will switch over to D. And the other volume control is the closer you get, the softer it gets. There's an on and off switch, so that you don't have to listen to it all the time. And there's also, as he noted, the LCD tone display. And it has 2 different types of output waveforms, a square wave and a sawtooth wave, and those sound different, so you'll be able to hear that when we demonstrate. Any questions? Cool. See you. Come on. And we have the volume over here, so ideally you could, like, if you needed to move between notes that were far away, you could play the note, cover it, do that kind of thing.
And the LCD tells you where you are, so you can like kind of.
It's very hard to play actual songs on this one,
Yes.
but really easy to play a scale though. So it's our project. So that's the sawtooth wave.
It's a little more buzzy.
Richer and harmonic.
Yes, richer and harmonious.
That's like a chiptune
More
sound.
musical, really.
I like it.
I know. That's amazing. Sounds like
Ta-da.
so interesting.